Hello everyone, myself Bhumi Patel, Assistant Professor at LG Institute of Engineering and Technology in Department of Electronics and Communication. Today we will discuss about the different example in mathematical models of the system. So, the first example is we can draw a signal flow diagram and solve the example using Mason's gain formula. So here the example is given. This is the mode of the system. Suppose this is our output signal. The first gain is 1, then G1, G2, G3, G4, G5 and G6. And this is our output signal. Here again the second part is given. Gain is G7 and the next one is G8. Here the feedback signal is given H2. Here it is given H3 and here it is given H1. So this arrow, forward arrow, is indicate the forward path of the system and the feedback arrow is indicate the feedback path of the system. So using Mason's gain formula we can simplify this equation and find the transfer function. So first of all find out total number of forward path. Here you can see that the first forward path F1 is equal to here 1 into G1 into G3, G4, G5 and G6. So first forward path is G1, G2, G3, G4, G5 and G6. Now the second forward path starting from the input and end with the output. So 1, G1, G2, G7 and G6. So the answer is G1, G2, G7, G6. Now the third forward path is here. You can see that 1 into G1 into G2 into G3, G4 and G8. So the answer is G1, G2, G3, G4 and G8. Now there is no again the forward path. So the second step is find out total number of single or individual loops. Now what is the loops that contain the forward path and the feedback path? So the first loop is starting from the first node and end with this node. So this is the first loop G4 H2. The second loop is here you can see that G6 and H3. So this is our second loop. G6, H3. Now the third loop is here you can see that G1, G2, G3, G4, G5, G6 and H1. So the third loop is G1, G2, G3, G4, G5, G6 and H1. Now again there is more single loop is available or not. So you can say that G1, G2 and G7, then G6 and H1, it is also a loop. So the single loop fourth is P41 is equal to G1, G2, G7, G6 and H1. Now the fifth loop is, you can see that G1, G2, G3, G4, G8 and H1. So the fifth loop is G1, G2, G3, G4, G8 and H1. So this is the 5 individual or single loop in this example. Now the step number 3, find out 2 non-touching loops. Okay, so first non-touching loop is, here you can see that loop number 1 and loop number 2 is not, the node is not common and there are non-touching loops. So the answer is G4, H2, G6, H3. Now the second non-touching loop is G1, G2, G7, G6, H1 and G4, H2. So the second non-touching loop is G1, G2, G7, G6, H1 and G4, H2. Now the third non-touching loop. So this is the loop G1, G2, G3, G4, G6 and H1, and this is again a loop G1, G2, G3, G5, G8 and H1. Here you can see that the one node is common. So there are 2 non-touching loop is available for this example. Now the fourth step is find out 3 non-touching loops. Okay, so P31 is equal to, here you can see that this is the first loop and this is the second loop, but the third, fourth and fifth loop, the common element is here. So there is no 3 non-touching loop is available. So the P31 is 0. Now the fifth step is find the delta. Now what is the delta? 1 minus summation of individual loop. So we have individual loop P11 plus P21 plus P31 plus P41 and plus P51 plus 2 non-touching loop. Here 2 non-touching loop is 2. So P11 and P22 minus 3 summation of 3 non-touching loops. So here you can write P13. So P13. So write down the answer. 1 minus P11 is equal to G4H1, G4H2 plus G6H3 plus G1, G2, G3, G4, G5, G6, H1 plus 41 is equal to G1, G2, G7, G6, H1 and P51 is equal to G1, G2, G3, G4, G8, H1 plus 2 non-touching loop is G4, H2, G6, H3 plus G1, G1, G2, G7, G6, H1, G4, H2 minus P13 is equal to 0. So this is the delta. Now find the value of delta 1. So delta 1 is equal to 1 minus all the loops that do not touch the first forward path. So here you can see that delta 1 is equal to 1 minus. Here you can see that all the loops that touch the first forward path. So the answer is delta 1 is equal to 1 minus 0 is equal to 1. Now delta 2 is equal to 1 minus all the loops that do not touch the second forward path, and the answer is 1 minus G4 H2. Here you can see that this is our second forward path. So the first loop is not touch the second forward path. Now delta 3. An equation of delta 3 is equal to 1 minus all the loops that do not touch the third forward path. And here you can see that this is our third forward path, G1, G2, G3, G4 and G8. So all the loops that touch the third forward path, so 1 minus 0 is equal to 1. So this is the delta 1, delta 2 and delta 3. So the final transfer function is nothing but the output upon input. Okay, so equation is F1 delta 1 plus F2 delta 2 plus F3 delta 3 upon delta. Okay, so F1 is equal to G1, G2, G3, G4, G5, G6 and delta 1 is equal to 1 plus F2 is equal to G1, G2, G7, G6 and the delta 2 is equal to 1 minus G4 H2 plus F3 is equal to G1, G2, G3, G4, G8 and delta 3 is equal to 1 divided by delta. Now to simplify this equation and put the value of delta, we can get the transfer function of this signal flow graph. So whenever the signal flow graph is given, we can apply always a Mason's-Gain formula to simplify this equation. Find the number of forward path, number of individual loop, number of 2 non-touching loop, number of 3 non-touching loop and so on, and find the value of delta. The equation of delta is equal to 1 minus summation of individual loop plus summation of 2 non-touching loop minus summation of 3 non-touching loop, and then next step is to find the value of delta 1, delta 2, delta 3 according to the number of forward path. If we have 2 number of forward path, we can find the delta 1 and delta 2. And the final transfer function is equation is F1 delta 1 plus F2 delta 2 plus F3 delta 3 upon delta. Put the value of forward path delta 1, 2, 3 and delta and simplify this equation. We can get the final transfer function of this system. Thank you everyone. If anyone have doubt, then contact me in this email ID.